There's a method that costs less than $3, and it can turn dirty, bacteria-filled water into something you can safely drink. Not a weaker version, not a temporary fix. The full effect. And people have been using it for centuries, long before bottled water ever existed. You've probably walked past the ingredients for this dozens of times without realizing what they can do. Sitting on a shelf, cheap, ignored, while entire industries quietly built billion-dollar empires around the idea that clean water must come from complex filters, expensive systems, or plastic bottles shipped across continents. But here's the part that doesn't make sense. If clean water has always been this simple, why were you never taught this? To understand that, you have to go back. Not 10 years, not 50, thousands. Around 2,000 years ago, in the ports of the Roman Empire, engineers faced a problem that could collapse entire cities: water storage. Large ceramic containers sat under the Mediterranean sun, filled with murky, contaminated liquid hauled from rivers and wells. Without treatment, disease spread fast. Entire crews of soldiers could fall within days. So they turned to something surprisingly simple: crushed charcoal, burnt wood reduced to a black, porous material, soaked into water and left to sit. Over time, something strange happened. The water cleared, the smell disappeared, and sickness rates dropped dramatically. Roman texts described it as black stone that drinks poison. They didn't know the word adsorption, but they understood the effect. Centuries later, across the world in Japan during the Edo period, craftsmen used a similar method. They produced a material called binchotan, a type of high-grade charcoal made from oak. It wasn't just for fuel. Villages placed these charcoal sticks directly into their water containers. Within hours, impurities began to bind to the surface. The water tasted cleaner, fresher, safer, no plastic. No electricity, no machines, just carbon doing what it naturally does. Meanwhile, in West Africa, traditional water purification systems used layers of sand, gravel, and charcoal packed into clay vessels. Water would drip slowly through each layer, emerging clearer at the bottom. These systems were used for generations, quietly, reliably, without patents. And then something fascinating happened in the 18th century. In 1773, Swedish chemist Carl Wilhelm Scheele began studying gases and filtration materials. Around the same period, scientists in France conducted experiments showing that charcoal could remove color and odor from liquids. By the early 1800s, naval ships in Britain were using charcoal filtration systems to store drinking water during long voyages. By 1854, during a cholera outbreak in London, early filtration methods using carbon-based materials helped reduce contamination in certain districts. It wasn't perfect, but it worked better than doing nothing. And that mattered. Then came the breakthrough. In the early 20th century, laboratories in Germany and the United States refined what we now call activated carbon. By heating charcoal to extremely high temperatures, they created millions of microscopic pores. 1 gram of activated carbon can have a surface area of over 1,000 square meters. That's roughly the size of 5 tennis courts, packed into a teaspoon. Think about that for a second. A single spoonful, with enough internal surface to trap contaminants, chemicals, and toxins at a molecular level. That's not folklore, that's physics. When water passes over this material, impurities stick to its surface through a process called adsorption. Not absorption, like a sponge soaking water, but adsorption, where particles cling to the surface like dust on glass. It's silent, invisible, but incredibly effective. And here's what should make you pause. This same principle, the same material, is used today in modern water filters, sold for hundreds of dollars. It's inside those sleek plastic cartridges, those branded filtration systems, those advanced purification technologies. The core hasn't changed, only the packaging has. So if this method has been known for over 2,000 years, used by Romans, Japanese craftsmen, African builders, and modern scientists alike, why does it feel like a secret today? Why does clean water still feel complicated, expensive, out of reach for so many people? Because at some point, someone looked at this simple, low-cost solution and realized it couldn't be controlled. Here's where the story shifts, quietly. The global water purification industry is worth over $300 billion. That includes bottled water, filtration systems, replacement cartridges, purification tablets, and infrastructure. And a significant portion of that revenue depends on one thing: repetition. You don't just buy clean water once, you keep buying it. Filters need replacing every few months. Bottles get emptied daily. Systems require maintenance, upgrades, subscriptions. It's a cycle, and it's incredibly profitable. Now compare that to a $3 solution that can last months, sometimes longer. There's a problem there. A cheap, widely available material that performs the core function of expensive systems doesn't fit neatly into a recurring revenue model. It doesn't scale the same way. It doesn't lock customers in. So what happens? The method doesn't disappear dramatically. No bans, no headlines, nothing that obvious. Instead, it gets reframed. Activated carbon becomes a component instead of a solution. It gets embedded inside proprietary cartridges, surrounded by plastic housings, marketed with complex language, sold as part of a system instead of something you can use directly. You're not told you can use it on its own. You're told you need the system. Think about that for a moment. The same material that costs a few dollars in raw form is sold back to you inside branded filters for 10, 20, even 50 times the price. And because it's packaged that way, it feels advanced, necessary, official. But the chemistry hasn't changed. Carbon is still carbon. And it still works the same way it did in Roman ports and Japanese villages. Modern studies confirm this. Research from institutions like the Environmental Protection Agency and universities such as MIT have shown that activated carbon effectively removes chlorine, volatile organic compounds, and certain heavy metals from water. In controlled tests, it significantly improves taste and reduces harmful contaminants. This isn't fringe science, it's standard. The difference is how it's presented to you. Imagine you own a simple container. You fill it with water. You drop in a piece of activated carbon. Over time, impurities bind to its surface. The water becomes clearer, cleaner, safer. No branding, no subscription, no recurring payment. Now imagine that same process wrapped inside a sleek device marketed as cutting-edge technology with replacement parts you have to keep buying. Same chemistry, different story. And that's the part most people never see. If you've watched this far, you already understand more about water purification than most consumers ever will. Subscribe and share this, because this is how knowledge like this survives, passed directly from one person to another without distortion. Because once you see it, you can't unsee it. Think about every time you've bought bottled water, every filter you've replaced, every system you've considered upgrading. Now ask yourself, what were you really paying for? Here is exactly what to do, and it's almost insultingly simple. First, you need activated charcoal or activated carbon. You can find it in aquarium supply stores, garden centers, or even online. A basic bag costs around $2 to $5 and can last for multiple uses. Make sure it's labeled for filtration or food-grade use. Next, rinse it. This step matters. Activated carbon often comes coated in fine black dust from the manufacturing process. Place it in a clean container and rinse it under water until the runoff becomes mostly clear. It doesn't need to be perfect, just clean enough to remove loose particles. Now take a container of water. This can be a glass jar, a bottle, or any clean vessel. Add the charcoal. A general ratio is about 1 tablespoon per liter of water. The water may turn slightly gray at first. That's normal. Then you wait. Within a few hours, the carbon begins doing its work. Impurities, odors, and certain chemicals start binding to its surface. If you leave it overnight, the effect becomes stronger. By morning, the water is noticeably clearer and fresher. If you want to go further, you can combine this with a simple layered filter. Place cloth at the bottom of a container, then add sand, then charcoal, then another cloth layer. Pour water through it slowly. Each layer removes different types of particles, improving the final result. The total cost? Roughly $3. The total time? Less than a day, most of it passive. Now compare that to commercial systems that can cost $50, $100, even hundreds of dollars over time. Same principle, different price. And yes, people still use this today. In rural parts of Southeast Asia, communities rely on charcoal-based filtration systems for daily drinking water. In emergency survival situations, this method is often one of the first taught because it requires minimal tools and widely available materials. Even modern camping gear sometimes includes carbon filters, just hidden inside cartridges. The reason it works is simple. Carbon has an enormous surface area filled with microscopic pores. Contaminants stick to that surface and stay there. The water passes through, leaving much of what you don't want behind. That's it. No mystery, no magic, just chemistry. And now think about the timeline. Roman engineers knew it, Japanese craftsmen knew it, West African builders knew it, early scientists proved it. And yet, somehow, you weren't told. A $300 billion industry depends on that gap. Not because the knowledge is fake, but because it's too simple, too accessible, too easy to bypass the system. But here's the truth. This knowledge never disappeared. It was simply priced out of your awareness. Chemistry doesn't care about branding. Water doesn't care about marketing. And nature has never charged a subscription fee. If this opened your eyes even a little, share it. Because every share cracks the wall that kept this hidden in plain sight. Every subscription keeps this channel digging deeper into the methods they assumed you'd never question. And the next vault opens soon. What's inside might change how you see every essential product you've ever been sold.